Well, it's around Halloween, so let's talk about zombies. Zombie stars. And here's a picture of one of them. In essence, what you're looking at right here, even though it might resemble some kind of an oceanic organism, is actually one of the strangest and one of the most extreme stars in the entire Milky Way. An extremely unusual remnant of a relatively old star that technically we've never seen before up until relatively recently. And as the title suggests, this is also a zombie star, specifically a star known as SN1181, a star we've discussed previously in some of the videos in the description, but this time we'll talk about it one more time because we now have this new incredible simulation showing us this unusual zombie star in a completely new light in 3 dimensions. And so, hello wonderful person, this is Anton. Let's discuss the very unusual, very strange, and still difficult to explain object referred to as SN1181, and of course discuss some of the recent discoveries. But here, just as before, let's start with a brief overview of what we actually know about this, and more importantly, how we know about this. And specifically, how we know that this is a zombie star, or I guess, a supernova remnant. And here the answer actually comes from ancient Chinese and Japanese astronomers. They made a record of what was referred to as a guest star. Ancient Chinese and Japanese astronomers usually use these for various prophecies, and today we know that pretty much all of these guest stars were either nova or supernova, basically distant objects becoming bright for anywhere from a few weeks to a few months and then disappearing into nothingness. And a lot of ancient Chinese texts by various Chinese astronomers mention many of these stars with very specific descriptions, allowing us to trace them where they most likely were located. In Chinese texts, these are usually referred to as Keck. Yeah, I butchered that one too, but that's basically how it kinda sounds like. And because in ancient China, these Chinese calendars were usually considered to be a kind of a symbol of imperial power, or technically dynastic power, many of these astronomers and astrologers were actually required to write down all of these records and of course conduct these observations, because a lot of them were also used in astrological divination. So for example, the famous Crab Nebula that appeared in 1054 was seen as some kind of an important prophetic event. Now around this time nothing major really happened, but the Chinese dynasty during this time still made a lot of different preparations. And so both Chinese and Japanese astronomers observed an object somewhere in the location you see right here. But up until 2013, we've never actually had any idea what they were basically talking about. Because usually we see remnants of supernova as either some kind of a major cloud or potentially some kind of a relatively powerful pulsar. Once again, Crab Nebula is a good example. But then, in 2013, an amateur American astronomer, Patchick, who was actually looking for various planetary nebula, or essentially clouds produced by stars similar to our Sun when they transition into white dwarfs, discovered his 30th object. This is referred to as PA30, an unusual infrared cloud that at first he believed was another planetary nebula. But it just seemed a little bit strange, with additional observations definitively confirming that it was very strange. Not only was it a very bizarre cloud that seemed to also contain very strange tendril-like tentacles inside, it also possessed an extremely bright and very hot object in the center. As a matter of fact, additional observations revealed that it seemed to possess not a black hole and not a neutron star, but actually an extremely hot white dwarf. A white dwarf with a temperature of 200,000 Kelvin, in essence making this the hottest star we've ever discovered. Just for a comparison, our Sun is only about 5,000 Kelvin. Not to mention that it was also unusually bright, and possibly also a little bit too massive. But here this was confirmed to be a supernova remnant for sure. Here we had expanding stellar winds with very high velocities of 16,000 km per second at least. But unusual composition. Only carbon, oxygen, and neon. No hydrogen, no helium. Which was very strange for a supernova remnant from a collapsing star, or even formed from a white dwarf. Moreover, it wasn't really clear why this had a white dwarf in the center, what happened to the neutron star. And so eventually, over the last decade, researchers were able to work out that this is potentially one of the rarest types of supernova we've seen so far. It's referred to as Type 1AX supernova, with one potentially visible right here as well, from observations in 2012, that basically involves two different white dwarfs, one made out of carbon and oxygen, and one made out of oxygen and neon, colliding and creating a supermassive white dwarf. A white dwarf that starts to spin really fast, produces huge temperatures and a lot of stellar wind, but also potentially is not particularly stable. As a matter of fact, it probably is going to go supernova again, maybe even relatively soon. But the extreme properties in this case, and specifically the extreme emissions and the temperature, seems to be explained by radioactive decay of nickel-56. The problem is that this isotope, even though it does produce a lot of heat and a lot of energy, also has a half-life of just 6 days. So here it doesn't really make sense unless the conditions inside this white dwarf are so extreme that they actually allow this nickel to continuously capture electrons, thus increasing its half-life from days to possibly centuries. And that's actually what seems to keep this white dwarf from basically shrinking and possibly exploding again. And though obviously there are quite a lot of mysteries with this star, another major mystery were these very bizarre tendrils. Tendrils, or filaments, you see right here, that were officially confirmed a few years back. And for a pretty long time, it wasn't actually clear what exactly these are or how they were formed. But more and more observations started to reveal that these didn't seem to be magnetic lines or shadows of any sort. These were actually signs of some kind of a ballistic ejection, or basically as if something relatively chunky and massive shot out from the middle of this object at some point in the past. And so in some of the recent studies, and specifically the study you can find in the description, by using the Keck Observatory in Hawaii, and specifically the Keck Cosmic Web Imager, designed to detect some of the faintest and some of the darkest sources in the night sky, with the main focus being the mysterious cosmic web, Tim Cunningham and his team were able to once again analyze the unusual properties of this very strange remnant, mostly focusing on these very strange tendrils. And in the process they confirmed that they indeed seem to contain ballistic properties and haven't actually slowed down much ever since their original release. But I guess much more importantly, they were also able to create this very unusual model, essentially showing us what it kinda looks like. And of course the video that shows us all of this in 3 dimensions that you can find in the description. And so what exactly are we looking at? Well, this unusual hedgehog is basically formed by very large chunks of white dwarf mass that was released at relatively high velocities in various directions away from the center. And all of this ejected material has been traveling in only one direction without slowing down for the past 800 years. And so here, by basically measuring the speed and tracking down where these chunks came from, they obviously all point in the center of the remnant, with the actual explosion occurring sometimes around 1151 plus minus 70 years. And that of course matches the observations from the Japanese and Chinese astronomers really well. In this case, this was actually determined by measuring the Doppler shift of specific emissions from sulfur present inside the filaments. And so this new impressive map basically shows us this bizarre formation in 3 dimensions for the first time, but also uncovers a couple of unusual mysteries. First, if you zoom in, you'll notice there's a very large cavity in the center. Basically, all of these remnants seem to start a little bit away from the center and not necessarily from where the white dwarf was located. So basically, for some reason, as the supernova was exploding and as the shell was expanding larger and larger, it suddenly produced these very large ballistic emissions. And it seemed to have happened at a very specific time in pretty much all directions. Now there's no explanation for why and how this happened, but that's what this image shows us. And the second mystery here is the unusual asymmetry. When measuring velocities of these unusual ballistic objects, the actual speed seems to vary by about 40%. In other words, some of them are 40% faster than other ones. And it seems to have a kind of a preferential direction. And that means that this was not a perfectly spherical explosion, and it also seems to possess an unusual sharp inner edge. But unlike the gas expanding from the star right now, that's moving at 16,000 km per second, these ballistic objects are moving much slower. Their velocity is only about 600 to 1000 km per second, which is probably because they also possess a little bit more mass. But in essence, this image and this 3-dimensional representation of the supernova remnant shows us previously unseen structures and very likely previously unseen supernova phenomena that most likely happened sometimes around 1181. For example, here it's implied that there was at least one reverse shock that very likely form this unusual bubble in the center, but we also see these very bizarre ejecta that are currently kind of difficult to explain. But the biggest mystery is still the actual star in the center. Since this is a very hot and possibly very unstable white dwarf, we don't actually know what's going to happen to it anytime soon. As a matter of fact, for all we know, it might go supernova again, maybe even during our lifetimes. And so as a result, this is very likely one of the most exciting discoveries in the last decade, and it's definitely going to be studied again and again just to find out what's happening here and what's going to happen in the future. But at the moment, this is almost definitely an extremely rare type of a supernova, type 1AX supernova, a result of a collision between two white dwarfs. And so instead of completely exploding, they exploded just a little bit, leaving behind a much more massive single white dwarf. And so once we learn something else, or there are some additional updates, we'll come back and talk more about this in some of the future videos. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.